FRQ Energy Math numbers 3 and 4. Letter A for number 3. Now remember to go ahead and read all of this before, so pause the video and read it ahead of time. Letter A, we're going to take 4 people. You can write it as persons. And each person showers for 10 minutes per shower, and it tells that here. So 10 minutes for each person per day. And each shower is 4 gallons per minute. So 4 gallons per minute. So now our minutes cancel out, our persons cancel out, and I'm sorry, the person up here, I have it in the wrong place because they cancel. It's per person day. So the people cancel out. And so we have here days, but we want to get it to years because the answer calls for a year. So we're going to take 365 days per year. So now my day, sorry this looks a little sloppy here, but my days cancel out. And all I have left is gallons per year, which is what we want in our answer. So 4 times 10 times 4 times 365. Once we do all of that math by hand, it's going to be 58,400 gallons per year. And that's our answer to A. Letter B, calculate the annual cost of electricity for the family, assuming that 3 gallons per minute of water is used from the hot water heater. So we're really going to take this number here and multiply it by 3/4. Why 3/4? Because it comes out at 4 gallons a minute, and 3 gallons a minute is from the hot water heater. So it's going to be a ratio of 3/4. And so that's the first part of letter B. So 58,400, we need to multiply that by 3/4. Or I can just take this number and multiply it by 0.75. So when I do that, probably the easiest thing to do on an AP test is to multiply it by 0.75. But when I do that math, I'm going to end up with 43,800 gallons of hot water is used in the shower. And then one of the 4 gallons is cold to make a mixture so it's warm and not boiling hot water. So now we're going to find out how much that costs. So we know here that the hot water heater, it takes 0.2 kilowatt-hours per gallon, and it costs 15 cents per kilowatt-hour. So let's go ahead and take 43,800 gallons times 0.2 kilowatt-hours per gallon. So now we know our gallons cancel out, so that's a good thing. Times 15 cents per kilowatt-hour. Now our kilowatt-hours cross out, and all we left with is dollars, which is good because it asks us up here what's the cost. So when we multiply this whole thing out, we end up with $1,314, and that's our answer. Letter C. Letter C says that they can replace their old hot water heater with one that uses half the amount of energy. So if they're only going to use half this amount of energy, it's only going to cost them half that amount of money. So how much money are they going to save in a year? Well, half of this. So let's just take this number and divide it by 2, and they're going to save $657 a year. So that's pretty easy math, but we're not done. And so it asks how many days would it pay back the new hot water heater. So let's find out how much money per day this is that was saved to get that started. So $657 a year is what's saved, and there's 365 days in a year. So our years cancel because I have 2 slashes here and then I can cancel them that way. So if I do this math by hand, it ends up, when I round, to $1.8 per day is what is saved. So my water heater cost $600, and if I take that and I divide it by the 1.8, I end up with, and this is 1.8 per day. My day can flip up to the top here for my answer, and I end up with 333 days. This is a kind of I would say this is a hard FRQ, especially B and C, and especially C. C is a little bit tricky. A, I think that is easier to understand, and it's pretty straightforward. B is a little tricky because you had to remember the 3/4 part, but other than that, it's pretty straightforward. And C is a little bit harder to know how to set it up. But remember, you don't have to get all 11 points on an FRQ. You only need about 5 points. So any FRQ that has math is also going to have maybe D and E and F that does not have math. So you can get a lot of points on the non-math portion, and try and do some of the easier ones to get another couple of points. And also attempt to do the harder ones, because sometimes if you set it up right, but even if you get the answer wrong, sometimes you do get points. Number 4. Alright, this one was an actual problem that was given a couple of years ago for my students. Go ahead and read it over and pause the video. And let's get started with letter A. Letter A asks for the number of kilowatt hours of electricity that can be produced in a year by the manure from the cows. So we have here that we have 200 cows, and they can produce 3.0 kilowatt hours of electricity per day. That's a pretty simple one. This would be easy points. 200 cows times 3.0 kilowatt hours per cow. So our cows cross out, and we end up with 600 kilowatt hours per day. But it asks for a year, so be careful when you read a question. So now I have to multiply that by 365 days per year. So 600 times 365 gives you 219,000 kilowatt hours per year. And that's my answer. Letter B asks you to take that number from A, and you're going to find out how much a year it saves. Well, electricity from the power company costs 10 cents per kilowatt hours. Well, now he's getting electricity for free from the cows. So the cows are giving him this much, and how much would he have to pay for this amount of electricity from the power company? So it's a pretty easy calculation overall. It's just 219,000 kilowatt hours per year times 10 cents per kilowatt hour. And so we just need to, because this is a 0.10, we just need to divide by a tenth. Multiply by a tenth, which is moving the decimal point one space over. So it's $21,900. The question asks you to round up to the nearest thousand. So we're going to round this up to 22,000. So that's how much the farmer will save a year in electricity costs. But he has to buy the digester. So how many years will it take to pay that back? So all we're going to do is take the cost of the digester, which is $200,000. And we're going to divide by $22,000. And that's going to give us the number of years. And when you divide this out and round it to the nearest whole year, we end up with 9 years. Letter D. Calculate the minimum number of cows the farm would need to produce 400,000 kilowatt-hours of electricity. Letter D. Letter D asks to calculate the minimum number of cows the farm would need to produce 400,000 kilowatt-hours of electricity per year. So we're going to take 3 kilowatt-hours per day per cow and multiply that by 365 days per year, and that's going to give us 1,095 kilowatt-hours per year because our days cancel. So 1,095 kilowatt-hours per year. And that is for one cow. So the farm needs 400,000 kilowatt-hours per year. And one cow gives it 1,095. So when we divide this, we end up with 365.3 cows. So basically the minimum number of cows that's needed is 365 cows is the minimum that would be needed for 400,000 kilowatt hours of electricity.